In this video, we're going to talk about graphing, just a little bit of an introduction to graphing in two dimensions, and then a little bit about slope of a line. And some of this might be familiar to you. You might have seen some of it in a introductory algebra course. And we're going to um, go over it with respect to the statistics. As always, this is Pathways to Statistics. And so our focus is on, leaning towards how this is going to be helpful to us in elementary statistics. So first of all, I want you to take a look at the schedule that we are here in week 14 already. So I see we're kind of getting to the end there. And so uh, we're going to cover section 7.1 and 7.2. And then later in the week, we'll have another video on 7.3 and 7.4. So let's go ahead and get started on this. And if you go into your book, and I'm in the ebook right now, in chapter 7, and you'll see Introduction to Graphing. And again, this is a topic that you probably, had seen or talked about before. And if you had algebra or even pre-algebra, and we're going to compare this to what we, graphs, things we had looked at already. So if you remember, we had talked about histograms. We talked about tables, graphs, and charts as descriptive statistics. So remember that descriptive statistics they're things that help us describe a sample. And we had descriptive and inferential statistics. We kind of broke statistics down in general to either descriptive or inferential. And inferential really had to deal with more about describing a population. So what we want to do here is think about, why did we have a histogram? Well, when we went out and collected a set of data values, so one set of data values relating to one variable. And we'll see here the variable is gross monthly salary. And that's it. There's no other variable or data that we collected. The data was on gross monthly salary. And so this was a one-dimensional uh, idea in a sense. And what we did was we took it and broke it up into groupings, right? We had all these different groupings. So this first bar here represented a group from $800 to $825. And this height listed how many people had a gross monthly salary between $800 and $825 in this particular sample that we collected. And it looks like it might have been about 25 or 30. There were like 30 people that had that. And then the next one ranged from 825, between 825 and 850. And there were more people that were in that particular range of values. They were up here, looks like maybe about 75 people fell into that. And then we had the next one, 850 to 875 was up here, and that was about 120 or so, and so on. So we could see it kind of went up and went down, and this relates to that we were talking about a normal distribution. This is kind of normal, and we would say it's skewed to the right because we got these high, remember, outliers. So a lot of this stuff we're talking about right now is very similar to things we've already talked about before. So what's different is that we're going to have a variable along here like our x-axis, And then we're going to have another variable that goes up. Now you say, well, this frequency is a variable. Well, yeah, in a way it is in a sense, but it's a count. It's a frequency table. We have groupings and then how many fall in each of the groupings. But we're going to actually have something different over here that we collected data on that's different from gross monthly salary. Okay, so we're going to be comparing two different variables, right? So let's go ahead and take this off of here. And for example, you may, in this first page here, they say, well, let's look at rows and seats. So if you were going to go to a theater or something, and then maybe you had to look and see where your seat was, and you would need two different numbers. You would need the row number that you're sitting in, and then you would need the seat number that you're sitting in. So the rows all have different seat numbers, and they're ranging from 1 through 10. So this particular seat is in row 5, seat 3. So we have a horizontal value here. We have this vertical column here. One has to deal with the row that you're in. The other has to deal with the column that you're in. So it's kind of a nice system for finding position. And in algebra, we kind of did the same thing. We look at this and we say, well, here's our x and y axis, and we use those to find position of some ordered pair of numbers. We could think of these as an ordered pair, and we could write it as 5, 3. 5, the first number being the row that you're in, 3 being the seat that you're in. So we could have another seat that would be 8, 9. So 8 would be row 8, and then we would go up to seat 9. So 8, 9 would put us right here. And then you could have 2, 6. So here we go, here to row 2, up to 6. So here's row 2. There's seat 6, so that would be the seat then that was 2, 6. And what we do is this is extended. So this is like the first quadrant. You'll see here we have positive numbers here, starting at 0 and going up this way, the origin, and then we start here and we go up this way. So if we were looking for 5, 3, we would start here at 0 and go out to 5 and up 1, 2, 3. So same idea. We go over with the first number to the right if it's positive, and then we go up if it's positive. So this is positive, positive. All these points in here are going to have x and y values that are positive. Now the difference, this is just positive stuff, and now this xy axis though can extend over here to the second quadrant, and there's a third quadrant down here, and a fourth quadrant. So we actually have these 4 different quadrants that can represent combinations of positive and negative numbers. These are both positive. We have negative x, positive y's in here. These are going to be negative x, and going down, it's going to give us negative y's. So negative negatives. And then these ones over here are positive x, and go down to get in here negative y values. So we got all that stuff covered. In statistics, we typically deal with mostly situations where we're in this first quadrant, but for now we're going to, again, just talk a little bit about some more plotting. So let's go to the next page. And remember that the ordered pair of numbers come from 2 different variables. So again, when we have an ordered pair, that means we're referring to 2 different variables. The first number comes from one variable. The second number comes from a different variable. So you could be talking about your scores on your math score, or maybe you took a math test and an English test. And we would let the math test be the first number and the English test be the second number. So you would have taken two different types of tests, but you could plot those and compare. So why are we putting on two variables? Well, we want to eventually talk about comparing those variables and see if they create some kind of pattern. And when we collect data, then we can talk about that pattern and what it might be telling us. And so it's true to the idea of statistics. And what we do with statistics, we collect data and it helps give us information about things. And in this case, we're going to be talking about relationships between two variables. So we're going to have an ordered pair of numbers. So we'll see right here, 3, 1. They had to start in the middle here, 0, 0 at the origin, go over 3, and up 1. Now we're there. -4, 2. Start in the middle. We go to -4, so we go either right or left first. That's that first number. So we go -4, up 2. Start in the middle. Go to the right 3 and down 1 to get to that point. 3, -1. And then this last point here, we go left 1, down 3, represented by these negatives. Okay, so there's could be zeros in there, and I want to show you there's kind of special points. The points that fall on the axes. Here's my x-axis, the horizontal axis. My y-axis goes up and down this way. So 0, 0 is right in the middle. Now we go over 1, 2, 3 to the right. That's the first number is 3. And then the second number means we don't go up or down at all. So we stop right there. That's considered an x-intercept because it's sitting on the x-axis. Now, this point right here is also sitting on the x-axis, but it's over here on the left. So we start here. We go 1, 2, 3, 4. So that's -4. The 0 means we don't go up or down. We sit on the axis. Now, that could also happen for the y value. Start in the middle. We don't go right or left. And then we go up 1, 2, and that's what this 0, 2 stands for. It's a y-intercept because we're sitting on the y-axis. All right. 0 for the first number means don't go right or left. You're just going up or down. Up 2. This one, 0, don't go right or left. Just go down 1 to get there. This is saying, okay, start at the origin, don't go right or left, and get down 1, 2, 3, 4 to get to there. Okay, so plotting points is pretty straightforward. And again, you may have done this before. So we're just going to move on. And here's some examples you can look at and try. In my math lab, there's some examples in there. And really, that's about all we need to talk about for that first section. Again, these points, what they are, what they're representing, right? Two numbers in an ordered pair like that, we have two variables. Each number is talking about something different. This may be, the first number might be how many miles you drove, and the second number might be how long it took you to get there. So you might have, if you start 0, 0, don't drive any miles, didn't go anywhere yet. And then if we see this point over here, this could be 5 miles, and maybe it's walking. We could say you went 5 miles and it took you 2 hours to get there. So it could be lots of different things. Any two things you could think of that are quantitative, right? These are numeric, the quantitative variables. And here's the quadrants we talked about and the different signs of the pairs of numbers in those quadrants. And again, you can go through and practice and check out some of these examples. Okay. Now, interpreting graphs, again, let's look at another example. This is time in hours, cost in dollars. It says the graph shows the cost of parking a car at a lot for T hours. So many hours, right? Describe the trend that you observe in terms of both coordinate plane and cost of parking. And really what they want you to see is that as time increases, right, it's going to cost us more money. So we start at 0, 0, no time, no money. And if we pick a point up here, then we would say, okay, well, let's say in 2 hours it costs us $20. So we'd come over this way 2 and go up to 20, we'd have a point there. And if we went out 3, maybe $30 and so on. Okay, here's another one. Following graph shows the cost of shipping charge on a package depending on its weight. So this line's kind of flat. It's saying that from here to here, the cost doesn't go up at all. Same price from here to here on weight. So it can weigh up to a certain amount. You don't get charged extra, but as soon as you pass this weight, this thing's going to increase. The cost is going to increase as the weight increases from this point here on. Okay. And again, you can look through some of those examples. And we're going to go on to the next section. And slope. Okay, so the one thing we want to make sure you understand about slope is that we're talking about really a straight line pattern. When we look at the next few sections, we're going to talk about something called correlation. And it helps if we can graph the data, just like with a histogram. And we saw that there was this normal kind of distribution shape to it, which allowed us to use maybe a normal distribution, a normal probability distribution to find probability. So we would like to be able to look at a set of data values and see kind of what it looks like. And then it tells us the type of model that we can build around or within those data points. So for this course, though, we're going to talk about ones where we have a straight line, where the points kind of resemble, or at least we're going to talk about them in terms of how well they resemble linear pattern. So slope, again, a lot of people get introduced by that and introduced to that in algebra. And so we take a look at here. It says slope, also called rate of change. Important concept in study of graphing. Now, again, graphing a straight line, right? And there's also slope, but when you get beyond straight lines, it changes. It's a little bit different idea. Same formula, but a little bit different idea. Something you would call instantaneous slope. But now let's take a look at this. And they're saying, okay, what if we had a straight line here? Well, what is this line representing? Well, it's representing an infinite number of points. So if you took and you just kept putting a bunch of points in a straight, path like this, you kept plotting and plotting, eventually it just looked like a straight line. And they're saying, hey, we're going to pick any 2 points on this line. And they picked this one here and this one here, right? We could have picked one up here, one down here, one here. Any 2 points, there's an infinite number of them, and it doesn't matter. Just so they're points off the line. And if we do that, then we can create a value that represents what we call the slope. So slope is just a value that's created from these ordered pairs. Okay, remember each point is located with an ordered pair of numbers. So each point is going to have an ordered pair. So we got two ordered pairs up here. And if you take those ordered pairs, you have two different x values and you have two different y values. For the most part, we have some special cases where we'll talk about. But so we have two x values, x1, x2, y1, y2. So it doesn't matter which one, what you call one or two. And they're going to say, here's our formula. You're going to take the one value minus the other. The y value is in the numerator, the x value is in the denominator. And they show, take the second point, y sub 2 minus y sub 1, and then x sub 2 minus x sub 1. So consistency. The 1 point, right, x sub 2, y sub 2 is here. See, this is the 1 point, the x and y value. This is the other point. We don't want to get these mixed up where that's first. So this is the 1 point x and y value. See right there, x and y value. Put the x and the y value right there. The other point, put the x and y value there. You can subtract. Okay. And that's going to give us a number. All right, it's going to give us the number. So the slope of a line passing through these points is defined in that way. X1 not equal to X2 because that would be 0. That's why they say that. Division by 0, undefined, right? Undefined. So let's take a look at, I'm going to move this out of the way. And we're going to do this one here. They said, let's say you have 2 points. If I can get over there, we go. Say 2, comma 1, and 4, comma 2. And we're assuming these are 2 points on a particular line. And we want to find the slope. So we're saying m, which is a symbol or letter for slope. Y sub 2 minus y sub 1. X sub 2 minus x sub 1. So m equal to. And they were showing, let's say this is the first point and this is the second point. Right? Okay, so let's take that second point and check that second point. Let's take the x and the y value from the second point. All right, isn't this the x and y value from the second point? 4 and 2. Here's the x and y value from the first point, 2 and 1. Right? This is my ordered pair, 4 comma 2, 2 comma 1. M equal to, it's 2 minus 1, and 1. 4 minus 2, 2. So we got a slope of 1/2. Slope of 1/2. Okay, that's it for that one. Let's try another one. And we're going to use, again, you can look at these in the book. So I'll use the ones in the book. And let's get to the next page. All right, so the next example is -3. So we have -3, comma 1. And 2, comma -2. And really the students, when they get in trouble, that's what they get these sign thing mixed up, right? So you got to be careful. Well, so let's write this out. So that's m equal to y sub 2 minus y sub 1, x sub 2 minus x sub 1, right? Formula, plug in m equal to. All right, again, we're going to say first point, second point. First point, right? Doesn't matter. First point, second point. All right, so let's take the x and y value from the second point. Well, here's my second point, right? Here's the x and y value. Here's the x value. Here's the y value. X and y value, right, from that point. And then minus, and then the x and y value from the first point. -3, 1, right? X and y, x and y. First, this is the second point, right? 2, -2, -3, 1. All right, once we make sure we get those in right, then we got to assume you know how to work with negative numbers. -2 minus 1 is -3. -2 minus the -3, and that's kind of +3. So 1, right? All right, so let's go ahead and -3. All right, so whoops. Yeah, I see I made a. I got to go back and erase this. All right. Whoops. All right, there we go. Yeah, so 2 minus a -3. Yeah, let me just do that again. I need to brush up my negative numbers. 2 plus 3 is 5. There we go. Okay. -3/5. Okay, there it is. We got it this time. Now, still trying to get used to working with this tablet, and I'm looking at the book at the same time on a different computer, so it's I'm getting more used to it, but I've never had done this before, so kind of have to bear with me. All right, let's go ahead and continue on. And look at some special cases. All right. All right, so we have 2 more points. All right. And this is going to be -1 and 7,5. There we go. Now I want to plot these over here for a minute. Up. I have to learn to get a straight line on this. -1, 5. Okay, so if I graph that, I get -1, 5. And I'm just kind of guessing over 1 up 5. Okay. And then 7, 5. I'm going to say is right here. X, Y. All right, so now if I draw the line, and again, this is straight through those, right? You got a line going this way with these 2 points. Now the line is horizontal. And when we talk about slope, we talk about kind of how much is this line, slanting up or down. This one's not slanting at all. So let's kind of like just verify that with the slope formula. Okay, so m equal to y sub 2 minus y sub 1, x sub 2 minus x sub 1. Again, I'm going to do first point, second point, and try to be careful on my computations here. Here's the second point, x and y value, right? 7 and 5. So 7 comma 5, and subtract, and the first point over here, negative 1 comma 5. So negative 1, 5. All right, so m is equal to 5 minus 5 is 0. 7 minus the negative, that's plus 1, right? It's going to give me 8, right? Add the opposite, so right, so we're going to add 8. But that gives me 0, so that kind of makes sense because we said there is no slope or 0 slope. So that works out. So again, this horizontal lines have slope of 0. All right. Let's clear that canvas out. And let's look at another example. And again, what I'm going to do is put the points up here, 3, comma, 1, and 3, comma, negative 2. So I'm going to graph this thing a little bit better on the vertical line. I got to work on that. How to get that. All right, so we got our x and y axis, 3, comma, 1. I'm going to go 1, 2, 3, and up 1. All right. And then for this point, 3, comma, negative 2, I'm going to go 1, 2, 3, 1, 2 down this way. All right. So I am going to see if I can all right, not too good. But that's supposed to be a straight line up and down. Okay. I'll figure out how to maybe draw those one of these days. Or there's got to be one here somewhere. All right, so we got that. And then let's check the slope. So we have a line that's straight up and down, a vertical line, m equal to y sub 2 minus y sub 1, x sub 2 minus x sub 1. First point, second point. Second point, x and y value gets here. All right, second point, negative 2, 3, x, 3, negative 2, right? So we have the x value and the y value of that same point, the x and the y. Minus, minus. And then the x and y value for the first point. So 3, comma, negative 1. So I'm going to put in 3, comma, 1 here. All right, 3, comma, 1. M equal to, this is going to be a negative 2 minus 1 is a negative 3. All right, this is add the opposite. So I have two negatives I'm adding to get this. 3 minus 3 is 0. All right, so division by 0 is undefined. Because how fast are you going up when you're going straight up and down? How do we represent that? It's like infinity or something, right? So fast. So yeah, we just say, well, it's undefined. We don't have any way to really define that where it fits in numerically. So good. So everything seems to be working. This is undefined, right? It's showing up in here. All right, so let's go ahead and we're going to move forward in the book. I'm going to bring that back over. In fact, I'm going to clear this out and bring that back over, wherever it is. Okay, good. All right. So in general, for slope, these things we're going to want to remember because we are going to talk about it with correlation in the next section, and it's going to be important for us when we talk about any linear correlation in statistics. So slope, you can have a slope going up or down, or straight across, or straight up and down. Now, if the line goes up looking from left to right, as we start on the left and we kind of go this way, if we were on the line and we were going to the right and we were staying on the line, then we're going up. It's positive slope. If we start on the left and we stay on the line and we follow it, we're going down, right? My cursor's going down, the line's going down, it's a negative slope. And then we just kind of reviewed, if it's straight across, well, it's a zero slope. And then if it's going straight up and down, it's an undefined. So these are 4 things you need to remember about possible slopes of lines, right? And here they're showing you can have more than one line. You could have different slopes. This one has a -3/2. This one has a -1, right? So you can have more you can compare on that. And we look at some examples here. Insurance reimbursement on dental bills. Well, this thing has a positive slope. So what does that tell us? As dental bill goes up, the insurance reimbursement will also go up. Okay. So let's look at another example here. Time of day, distance traveled. Well, as the time of day increases, the distance traveled also increases. And we'll again get to this a little bit more here and I think that's it for section 7.2 in your book, and it looks like that's about it. So we're going to stop there, and then in the next video, again, we're going to pick up in section 7.3 and, yep, seeking correlation.